Okay. So the first one, write the ionic, I should be more formal, write the ionic compound formed between magnesium and oxygen. What group is magnesium in? 2. So what's the charge? 2 plus 2. And notice they have main group. You know, they have like group 1, 2, and they call them like 1A, 2A sometimes. And they have the transition metals, those are all the B's. Then it goes back to the main group. So when I say what group, I call it 1, 2, 3, 4. 1 through 8 are the main groups. And then oxygen, it's back in the main group. What group is it in? Yeah, you need a periodic table to get used to it. I can see you mouthing it. 6A. So what's the charge? 2. Okay, so if I crisscross the way we've been taught, I would get this. Is that right?
No. Yes, it didn't.
Not with an ionic. And you don't crisscross the non-ionics, you only crisscross the ionics. So basically, no. All right. What should I do? Divide them so that they have the lowest number possible. So divide them both by 2, and then what do you get?
MgO.
Yeah. So there's your final compound. Magnesium oxide, like that. Okay, name this one. What's the NO3 again? Polyatomic ion. It helps to remind you that it's a polyatomic, not only because here's your metal, and then you have like more than one atom next to it, but it's also in parentheses. And remember, polyatomics are only in parentheses if there's more than one. So, but when it's in parentheses, you can see it pretty quickly. But do you remember what the NO3 is called? Nitrate. Nitrate. And it's the most common. Anything that is named ATE, they all exist in nature. It means it's the most common. So they had to actually analyze, find the most common, name them 8. It would have been nice if they're like, anything that has 3 oxygen, let's call it 8. Then we'd have a rule. But they didn't. They were like, anything that's most abundant, let's call it 8. And then this is nickel, but do I just say nickel? Like if I left it like that, is that correct? No, nickel's a transition metal, which means it can have different charges. What's the charge on this nickel? Remember, you can go like this. We don't write the 1. But would the 1 charge go here? Would it match the nitrate? Is it a -1? It is. So that means that the 2 charge would match the nickel. So it's nickel 2. You just have to know the charge on this to be able to figure out the charge on this. And you should always know the charge on the anions. Yeah. You should, on the second one, which is always the anion, the negative charge, you guys should always know those because they're either polyatomic that you had to memorize, or it comes from the periodic table, which you know which group it's in. So you don't. So that's how you assign it. You don't have to, even without the reverse. I call it reverse crisscross. This one is -1 times 2, -2. There's only one of these, so +2. Same idea, just a different way to get there. Okay, name this one. I'm going to check that you can reverse crisscross or name it again using the Roman numerals because we use Roman numerals for the transition metals. Do you remember which transition metals do not use Roman numerals? There were 3. They make an L on the periodic table. Zinc, silver, and cadmium. They're all right next to each other. They're actually in group, yeah, they're right next to each other, they make a little L shape. But everything else, including, there's a couple that sneak out outside of the transition section, like 10, do you remember that one? That can have transition charges. Also lead, those are the 2 that sneak out and can also have transition charges. Okay, so here's the question. I'm going to show you the 2 ways to do this again. So what's the charge on oxygen? Now it's oxide. Because as soon as it's paired with the metal, it's an I. If it's by itself, not a polyatomic. So what's the charge on this? 2. How many do we have? -6, which means this has to be +6, but how many do we have? So each one is +3. But you could go like this. Would this charge match this if I did that? Yes. Which means this charge will match this. So that is a thing that works like 95% of the time. So now we know that it's nickel 3 oxide. And again, it's oxide IDE because it's not a polyatomic. There's only like 3 polyatomics that are IE. Okay, now over here. Potassium and sulfur. What group is potassium in? Yeah, group 1. So K plus. And sulfur, which is now sulfide because it's going to have a negative charge. 6, yeah, just like the oxygen. 2 minus. So when we crisscross, do you bring down the 1? No, you only bring down numbers that aren't 1. So K2S, potassium sulfide, it looks weird. But why don't we say dipotassium? We don't say dipotassium, why don't we? Is potassium a metal or a non-metal? It's a metal. It's so weird because you're not ever like, I'm low on metals, I'm going to go eat a banana. But it is a metal. Everything in group 1 except for hydrogen is a metal. I think group 2 is a metal too. Okay, what is nitrite? I mean, what is the formula? Again, I didn't write this out very well, but I was trying to save board space. So what does nitrite look like? You know, nitrate is NO3. So what is nitrite? Right. So you only have to memorize the 8s. Just take an oxygen away, same charge, same structure, 1 less oxygen, you know the ites. It saves you so much time. And the 8s, again, were named because they're the most abundant in nature. So nitrites are actually what causes the migraine, when I was talking about that. But the saliva will convert the 8s into ites as well. Okay, name SF6. This was the one that people can inhale and it makes them talk really low. Remember that? Do I say sulfur fluoride? No, I have to say sulfur hexafluoride. Why am I using a prefix?
Because it's a.
It's nonmetals.
Yeah, 2 non-metals.
2 nonmetals, or a nonmetal and a metalloid. Those are the only ones that use prefix. Why don't I say monosulfur? Yeah, we never say mono for the first one. We rarely say it for the second one. We drop 1s wherever we can.
Is there no correlation between the substrate